Okay, so number one, we're dividing polynomials. The best way, easiest way to do this, and there's usually various ways for all of these problems to do this, but I'm going to break it up each term here. I'm going to divide by 5r to the 4th power. So it'll be broke up like this: 5r to the 10th power over 5r to the 4th minus 5r to the 8th over 5r to the 4th. And then we can simplify each term individually. So for example, 15 and 5 can both be divided by 5, so that makes this 1 and 3. And then r to the 10th power and r to the 4. Imagine like 4 r's listed out and then 10 r's listed out. 4 of the r's, all 4 r's would cancel here, 4 r's would cancel here, and you're left with 6 r's. And then 5 divided by 5 is just 1. That cancels. All 4 of these r's would cancel, and we're left with 4 r's up here. And then for this last term, divide both 5 and 40 by 5 to get 1 and 8. And then 4 r's on the bottom, 2 on the top. These 2 would cancel, and then it'd be 2 left on the bottom. And then we just clean it up, and that's going to be our answer. So 3r to the 6th power minus r to the 4th plus 8 over r squared. And that is the answer. Okay, then number 4, use synthetic substitution to find f of -3 and f of 4 for each function. So all you have to do is plug these numbers into the function and solve. So right here, we'll just do -3 squared plus 2 times -3 plus 3. So there's one of the values. And then for the second one, same idea. So the answer is 6 and 27. Okay, then for number 5, we are simplifying these. Same kind of idea. We're looking for common factors and for things to cancel. 9 and 27 both have the common factor of 9. So I can divide both of those by 9. I get 1 and 3. Then a squared and a to the 4th power. Both of these a's would cancel, and we'd be left with 2 a's on the bottom. Then all 3 of these b's would cancel, and you're left with 1 b right here. And then c doesn't have anything to cancel with. So then once you do all that, you can just write what you have left over. 1 over 3a squared, 1b, and a c. And that's the answer. Okay. Then number 6, we're going to break everything up into factors and then see what factors cancel out. So for this one, we're going to use that method that we reviewed yesterday, where you multiply a times c, and you have b. So a times c would be -30, and b is -1. You need 2 numbers that multiply to this and add to this, and that would be -6 and +5. And so now I'm going to factor this out. So 2k minus 6, 2k plus 5, and then if you have a common factor, you're just going to factor that out. So these are the two factors that make up this. And then for this part on the bottom, that's a little bit easier. It's just going to be k plus 3, k minus 3. And then cancel out anything that'll cancel. The k minus 3's cancel. And then you'll just write it like this. 2k plus 5 over k plus 3. Okay. Number 7, we have two fractions here, but we're dealing with multiplication, so it's almost like one big problem, and everything's multiplied by itself. So anything on the top, whether it be this fraction or this fraction, can be canceled with anything on the bottom, and that's what we're looking for. So let's see. These two u's would cancel, and we'd be left with one u right here. The y and y squared, this y would cancel, and we'd be left with one y right there. The x's here, this x would cancel, leaving only two x's up here. And at this point, let's see, then also the numbers can simplify as well. Negative 2 and 14 can, what's that?
Never mind.
Okay. Negative 2 and 14 can both be divided by 2, so I'd get negative 1 and 7. And then 15 and 25 can both be divided by 5, leaving 3 and 5. And then it might take more than one step to really clean this up all the way. But let's see, negative 1 times 5 would be negative 5. I have one u here. And an x squared. And then on the bottom, 3 times 7 is 21. I have a y and a z to the 5th power. And when I wrote the letters, I wrote them in alphabetical order as well. Okay, next. This is very similar to the last one. The only difference is we have a division symbol. And when you have the division symbol, you need to use keep, change, flip. So we're going to keep the first fraction, change the sign, flip the second fraction. As I rewrite this, I'm going to factor stuff out as well. So for example, with 4y plus 20, I know I can factor 4 out of both of those terms. So as I rewrite it, I'm going to be doing that as well. So 4 times y plus 5. Leave it as y minus 3 over here. Change the sign to multiplication. And flipping this and also factoring it at the same time. 2y and negative 6 can both have a 2 taken out. So 2y minus 3 over y plus 5. Then I'm going to cancel anything that is on the top and the bottom. So y minus 3 cancels with y minus 3. Y plus 5 cancels with y plus 5. 4 times 2 is 8, and 8 is our answer. For the next one, now we're dealing with subtraction. When you add or subtract fractions, you have to have a common denominator. And we do not have a common denominator here, so we're going to make a common denominator. For this one, I need 2 more x's, so x squared. For this one, I need 2 more y's, and then also this number needs to match as well. So I'm going to multiply this by 12x squared to make 2 more x's. And then whatever I do to the bottom number, I also have to do to the top.
Are you not adding y to that? Don't we need more y's?
So we'll need more y's over here.
So, okay.
Yeah, so over on the other one, over here, I'm going to multiply this by 5 y squared and 5y squared.
Gotcha.
And I'm like triple checking to make sure I got the right. Okay. And then I'm going to rewrite it with all of this mumbo jumbo. So 5y squared times 5 would be 25y squared over, now we have 60 x to the 4th, y to the 3rd, minus 1 times 12x squared is just 12x squared over 60 x to the 4th, y to the 3rd, and then these should match at this point. I would simplify more if I could, but I really can't, so I'm going to write it like this. And that is the answer. Number 10 is the same idea. You need a common denominator to add these two fractions. So first things first, I'm going to break these up into factors to see how in common or not in common these are. So y squared minus 16 would be y plus 4, y minus 4. And then over here, this would be y plus 4, y plus 4. These are similar, but they're not the exact same. So what we're going to do is we're going to add a y minus 4 over here. And whatever you multiply the bottom by, you also have to multiply the top by. And then over here, I need to add another y plus 4. Whatever you multiply the bottom by, you have to multiply the top by. Okay, so now we have common denominators. I'm going to FOIL both of these out. I'm going to kind of run out of room. It gets squeezed down here, so it'll look like that. It gets squeezed. But I can fit it because I've done it before. So foiling both of these. That was fun.
This is
It just like combines everything. Yes.
Can you zoom in a little bit?
Zoom in? Yeah. Okay. Then we're going to combine like terms and then put it over the common denominator. So I have a y squared and a 3y squared, so that would make 4y squared. Then 3y, 4y, negative 12y, and negative 2y would make negative 7y. And then 12 plus 8 plus 20 over the common denominator. Y plus 4 squared, y minus 4. That was fun. Don't take longer than 5 minutes, please. Okay, next one. Similar type of problem. This time we're solving for k, not just simplifying. In order to do this, we do need a common denominator for everything. If I break this up into factors, two numbers that multiply to this and add to this would be negative 4 and negative 3. So this would be k minus 4, k minus 3, broken up into factors. Why is it so blurry? Okay. Then over here, we need common denominators for all of these. So I'm going to multiply this by k minus 4, which you'd also multiply the top by k minus 4. Multiply this by k minus 3, and you also have to multiply the top by k minus 3. And then I'm going to rewrite it. So 3k minus 4 plus 4. Oh wait, that would be minus 12. Apologies. And then 4k minus 12 over Now these denominators will just cancel them out. Like if I was to multiply this whole thing by k minus 3, k minus 4, I could cancel out the denominators of everything. So just get rid of them, and then we have 7k minus 24 equals 25. 7k equals 49. K equals 7. Oh, okay. Number 12, 6th root of 64. So what we're going to do is break this up into the smallest of factors and hope that there's 6 of something that we can pull out. So breaking it up, 8 and 8 comes to mind. 4 and 2. 2 and 2. Okay, so with 6th root, if there's 6 of the same number, then you can just take that out. So 1, 2, 3, 4, 5, 6, there's 6 2's. So the answer is just 2. Okay, number 13. Now we're doing the cubed root, so we're looking for 3 of the same number. So for 64, I'm just going to break it up again. Actually, I already know there's going to be 6 2's because we did it in the last problem. Okay, I'll still do it.
And that R is broken up like 2 R's, right?
We'll get there in a second. Okay, so I got 2 groups of 3 because now we're doing 3 cubed root. So 2 times 2 is 4. So so far I have this. And that's negative 4. Okay. So the r squared we actually can't take out. If there was r cubed, we could take it out and put 1 r on the outside, but 2, there's not enough. But for the 15, let me just review what we did when we did learn this. We would take this number and put it over 3, 15 over 3, and we got 5. So we're going to take w to the 5th power and put it out here. If there was a remainder, then we'd take out like w to the 5th power and then leave the remainder inside. So negative 4 w to the 5th power, and then leave r squared inside. Thanks. Number 14, cubed root, but this time we have like this fraction. What we're going to do is just break it up. Cubed root of 216 over cubed root of 24. Robert, is it emergency again? Oh, I should record. Okay, so breaking this up, we're taking anything that has 3 of the same factor. So 216, cubed root of 216. I'm breaking this up. How did I do it in the last one? I broke it up, divided by 4 and 54. So we 2 and 2 here. 54, maybe 6 and 9. 3 and 3. Okay, so I got 3 3's, and then 3 2's. I don't know how I want to circle this. Okay, 3 2's. So 3 times 2 is 6.
What did you, how'd you break up 54?
6 and 9. Then it was 2 and 3, 3 and 3.
Gotcha.
And then there's 3 2's and 3 3's. So that'd be 2 times 3, which is 6. Over. And then for 24, I'm going to try to break that up. Wow, it's blurry. There's 3 2's. So 2 square root of 3. Well, cubed root of 3. Here, that 2. Okay, we can't leave the cubed root in the denominator. So to get rid of it, like if I was to do cubed root of 2 more 3's, then I would just have 3, if that makes sense. And then whatever I do to the bottom, I also have to do to the top. So cubed root of 3 times 3, which is 9. So now I have 6 cubed root of 9 over, and then cubed root of 3 times 2 more 3's cubed root would be 2 times 3, which is 6. So I have 6 cubed root of 9 over 6. 6's cancel, and I'm left with 9 cubed root. In my opinion, that was the hardest one on the page. Okay, again, 15, there's different ways we could do it. I'm going to just break up 24, see if I can take numbers out. Pair of 2's, so I get 4 square root of 6. Then for 18, take out a 3, be 21 square root of 2. Then 4 times 21 would be 84. Square root of 6 times 2 would be square root of 12, which I can then break up. 2 times 184 is 168, and I'm left with just a square root of 3, and that's the answer there. Number 16, fourth root of 405. Breaking it up, I'm looking for the same number. 405, if I divide it by 5, I get 81 and 5, which this would be 9 and 9, 3 and 3. So we got 4 3's, which I can take out. So this will be negative 3. Fourth root of, will be a 5 left over inside the radical. Okay, for 17, we're going to first just get the radical by itself on one side of the equation. So subtracting 3 from both sides, square root of 2p equals 7. Then the next step, to get rid of the radical, square both sides, we get 2p equals 49. Divide both sides by 2. And p is 49 over 2, and that's what's actually in the answer choices. It has it written as a fraction and not a decimal. Number 18, square, x equals 64. That was the easy one. 19, it has a fifth root, so just do fifth up to the fifth power here and fifth power here. Then we're left with w minus 7 equals 1 to the fifth power would just be 1, like 1 times 1 times 1, yeah. And then add 7 to both sides, and w equals 8. Okay, getting the radical by itself over here, subtracting 6 from both sides, get cubed root q minus 4 equals 3. Then to get rid of the radical, cube both sides, then we're left with q minus 4 equals 3 to the third power would be 27, plus 4, q equals 31. Last but not least, number 21, square both sides to get rid of the radicals. You get 2x plus 5 equals 2x minus 1. Subtract 2x, and you get 5 equals 1. Say what? When that happens, that means there's no solution. Might be, but yeah, it is. Okay, and that's it. Yeah, so you have the rest of class to either work on EverPy or whatever you need to catch up on. You can get your phones if you'd like. That's cool. If you're here today and you did this, you get full credit. I'll come around and just spot check, so leave it out.